given x of t graph, find the general expression for the Fourier coefficients a sub k. So the best way to do this to start is we need to pick out what our period is. There's multiple ways to go about this. The way that I like to do it is I like to start at the end of one and go to the end of another. So our period is from 2 to 10 milliseconds. So that would be 8 milliseconds equals t sub 0. Okay, so now we need to plug in everywhere we have an amplitude, we're going to plug in. So I'm going to show you what that means. Do not plug in the t0 or the period yet. It will solve itself later, so don't worry about that part. So we have 1 divided by t sub 0 from 2 to 4. So from 2 to 4 milliseconds, we have an amplitude of 4. So we're going to have 4e to the negative j 2 pi kt divided by t0 dt. We also have plus, then we have from 4 to 10. So we have the integral from 4 to 10. Our amplitude is 0 dt, because you're going to have e to the negative j 2 pi kt all over t0. This here would get plugged in here, but it is 0. 0 times anything is going to be 0. So we can leave that alone. And now all we have to worry about is 1 divided by t sub 0 from 2 to 4, 4e to the negative j 2 pi kt divided by t0 dt. The first thing that I always like to do is I like to pull this 4 out. It just makes it a bit easier. So I'm going to have 4 divided by t0, the integral from 2 to 4, e to the negative j 2 pi kt divided by t0 dt. Now the integral of e to the power of anything is e to the power of anything all over, and then we're going to take the reciprocal of this. So I'll show you exactly what I mean. So it's going to be 4 t0, take the reciprocal, so it's going to be t0 divided by negative j 2 pi k. We don't include the t because we're taking the integral with respect to t. Times, and then we have e to the negative j 2 pi kt divided by t0 from 2 to 4. Now we will plug in t0. And the reason I said that we shouldn't do that is because those will always cancel out. So at this step, this is when you want to plug in your t sub 0. So I'm going to have 4 all over negative j 2 pi k. Now, yes, we can, simplify the 4 and 2, but don't do that because sometimes we need the 2 and then it just becomes repetitive where we plug it back in. So don't do that. Now I have times e to the negative j 2 pi k 4 divided by 8 minus e to the negative j 2 pi k 2 divided by 8. Now if you notice, this, and this will cancel out. This, and this will cancel out, and I'm left with 2. Because over here, you have 8 divided by 8. 2 times 4 is 8, so 8 divided by 8 is 1. 2 times 2 is 4. 4 by 8 is a half. So let's rewrite this. So I have 4 all over negative j 2 pi k times e to the negative j pi k minus e to the negative j pi k divided by 2. Now, these are different, so we need to pull something out of it that is between it. So, the first thing I always like to do, make common denominators. This is 2 pi divided by 2. So, if I draw a number line right here, and this was negative pi divided by 2, and this is negative 2 pi divided by 2, what is in the center? Well, the best way to really look at this is, let's look at our unit circle. This is negative pi divided by 2, and this is negative pi. Well, what is in the center? In the center is negative 3 pi divided by 4. And you can also think about it as right here is pi divided by 2, so this is plus or minus pi. What is the angle right here when this is 45 degrees or this is 45 degrees? It's 3 pi divided by 4. So I can pull out a negative 3 pi divided by 4. So now I really want common denominators between all of them. So I'm going to do this one more time, but I'm going to make common denominators between all of them. So this will be negative 4 pi divided by 4, negative 3 pi divided by 4, and negative 2 pi divided by 4. So let's go ahead and take a look. So we're going to do, I'm going to do the same thing, 4 all over negative j 2 pi k. Make sure I wrote that down correctly. Yep. Now I'm going to pull out an e to the negative j 3 pi divided by 4. And I'm almost positive, yes, and there's a k in there as well. Now, what times e to the negative j 3 pi divided by 4 gives me negative pi? And the answer to that would be e to the negative j pi k divided by 4. And then I'm going to have minus e to the j pi k divided by 4. Now, the next thing I need to do, let me double check this. Yep. The next thing we need to do is I'm going to distribute this negative in. And I'm going to rearrange it. So you'll see exactly what I'm talking about here in 1 second. So I have 4 j 2 pi k e to the negative j 3 pi k divided by 4 times e to the j pi k divided by 4 minus e to the negative j pi k divided by 4. Now you may ask me, well, why did you do that? Well, if we remember, the sine of theta is equal to e to the j theta minus e to the negative j theta divided by 2j. Well, we have something super close to that. If this is my theta, this is my theta, what do I need to add? Well, I need to take this 2j and put it under. So let's go ahead and do that. So I'm going to get 4 divided by pi k e to the negative j 3 pi k divided by 4 times e to the j pi k divided by 4 minus e to the negative j pi k divided by 4, all divided by 2j. Now we're in sinusoidal form. So I can say this is 4 divided by pi k e to the negative j 3 pi k divided by 4 times the sine of pi k divided by 4. And this is our final answer. This is a sub k. So I can figure out any, a sub k if I were to plug in 1 for k, 2 for k, 3k for k, 4 for k, and so on and so forth. I can get back my value. So this is how we accomplish that. So just reiterate the steps one more time. The very, very first thing we do is we find our period. Our period is when it repeats. So our period was from 2 to 10, which is a difference of 8 milliseconds. Then I go ahead and I write out my formula. So I have 1 divided by t sub 0, and then I have from 2 to 4, 2 to 4, and I have 4 e to the negative j, 2 pi kt divided by t0 dt plus, and I do that for any, if I were to have more amplitudes, like say I had amplitude here of like negative 6, then I would throw the negative 6 in here and then work that out. Once I'm there, I pull the 4 out. I like to pull the coefficient when I can. If I cannot, so if I had another one which was like plus, 6 e to the negative j 2 pi kt divided by t0 dt, remember I cannot pull out this 4. I have to work with it, and that's perfectly fine. That's not an issue. I can pull that 4 up front here, if you remember our integral rules, and we can work it that way. But remember, this t sub 0, this t sub 1 divided by t sub 0 is multiplied into each of them. Next, we take the reciprocal, we cancel our t sub 0s, then we plug in our t sub 0, we go ahead and we simplify, we find what's in the center, we figure out what would go into both of them, and we try to make it into a sinusoidal form. And once we get a sinusoidal form, then we are done. If you have any questions, please go ahead, leave them in the comments. I'm more than happy to answer any questions you have. Thank you.